Hello friends, this is part 2 of solved paper Astronomy and Physics Astrophysics DSE paper 2, right? 2022 5th semester of Dibrugarh University. And if you want to follow me on Insta, this is my Insta ID Oza Lakhajit LAKHYAJIT 123. This is the Insta ID. You can follow me on Insta. And I have provided a Facebook link also in the description box. If you want to follow me on Facebook, then you can follow me. And before we start, please subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you, and do hit the bell icon so that you get notified when new video will be uploaded. So now let's start. So we have already solved question number 1, all the MCQs of question number 1 in the first part, right? And the playlist of this paper gonna be appearing at the end of this video, at the end screen. Okay, so now question number 2a. So what are the circumpolar stars? Here I'm not gonna explain each and everything, just I'm gonna explain the numerical only. So answer to the first question is this one. Okay, just take the just pause the video and take a screenshot, or just pause the video and you can note it. Okay, note it down. Next question is the difference between the terms absolute magnitude or an apparent magnitude of star. So let me show you the difference. Here is the answer to question number 2b. This is the answer, and this is absolute so let me make it correct. There is a spelling mistake. Absolute magnitude, and this is apparent magnitude. These are the difference in two columns, right? So take the screenshot or just pause the video and note it. Now let's move on to next question. So our next question is the apparent magnitudes of two stars are 0.06 and 1.01. Calculate the ratio of their brightness. Okay, now you see apparent magnitude, and I'm gonna use the symbol M1 and M2. Okay, for apparent magnitude 0.06 and 1.06, right? And the here you see, let me take a blank slide where I can show you that. Just let me do here, and we have enough space here. Just wait. So this is the solution to 2C, question number 2C. So apparent magnitudes of the two stars given. Apparent magnitude of the two stars are M1 and M2. These are the apparent magnitudes, and brightness ratio is given by 10 to the power 0.4 into M2 minus M1. Just remember this formula, M2 minus M1. So if we put the value of M2 and M1, then we're gonna have 10 to the power 0.4 into M2 is 1.06 minus M1 is 0.06, right? Just wait. 1.06 minus 0.06, and if you subtract that, then that's gonna give you 10 to the power 0.4 into 1, which is nothing but 10 to the power 0.4, and this is the required ratio. So what we have got, 10 to the power 0.4. This is the required ratio. So hope you have understood this. Now let me give you the answer to question number 2D. Here is the answer. You can see this is 2D. Okay, next question, take the screenshot. Next question, let me give you the answer to question number 2E. Let me explain it. 2E. Here is the answer to question number 2E. What was the question? Let me go back to the question again. You can see clearly that the surface temperature of two stars, A and B is the same. Okay, surface temperature of the two stars A and B. Let me take surface temperature of both is suppose capital T, and luminosity of A is higher than luminosity of B. So I'm gonna represent luminosity of A by LA and luminosity of B by LB. Okay, and luminosity is given by sigma A T to the power 4, where A is the surface area and sigma is the Stephen Boltzmann's constant. So let me explain. The surface temperature of the two stars A and B is the same, so I have taken this one as capital T. Capital T is taken as the surface temperature of stars A and B. Okay, and I have considered LA is the luminosity of star A and LB is the luminosity of star B. Okay, luminosity of star B. So here you can see luminosity of star B is LB. Okay, so I have used this formula, L is equal to sigma A T to the power 4 to find the luminosity of A and luminosity of B. Okay, so here instead of A I have written SA to represent the surface area of star A, and to represent the surface area of star B I have used here SB. Okay, so this is the surface area of star B, and now you see in the question it is given that luminosity of star A is higher than the luminosity of star B. Okay, this is given in the question, so that's why let's put the value of LA and LB here, and here you can see clearly that in this, from this relation, both the stars have the same temperature, surface temperature, and this is the sigma, which is the Stephen Boltzmann's constant. So in both sides, sigma and T, these two are same, so that's why the only quantity, the only thing which makes these two sides different is surface area, right? From this, now you see this implies that surface area of A is greater than the surface area of star B, right? So here I have written star A is the bigger in the size because both have the same surface temperature. Here you can see both have the same surface temperature. If the surface temperature of the two stars same and sigma is same for both, so in that case only thing that makes different, that is size. Okay, surface area. So that's why star A has higher luminosity because of its larger surface area. So A must be bigger in size compared to B. Okay, so hope you have understood this. Now let's move on to the next question. Now question number 2F. So I'm going to show the answers of this question 2F, G, H, I respectively one by one. Okay, let me show you. Take the screenshot, pause the video and take the screenshot or take the note. Okay, so here is the answer to question number 2F, and this is the definition of luminosity, right? And that is 2G. Pause the video and note it. And 2H, then we have 2I, right? So remaining questions will be solved in the next part. So thank you for watching. See you in the next video. Take care.